Bismillahirrahmanirrahim. Hello students, welcome to another video. This is Hamza Noor from Aero Education Network, and here's basically the follow-up of the previous video. We were discussing past paper questions of contact forces, the subtopic of forces and equilibrium. Okay, we have particularly some past paper questions from the handout, and in my previous video I discussed question number 5 to question number 7. This one is question number 8, which is May June 2010, paper 4, variant 2, question number 3. It says that a small ring of mass zero point 0.8 kg is threaded on a rough rod, okay, which is fixed horizontally. The ring is in equilibrium, acted on by a force of magnitude 7 Newton, pulling upwards at 45 degree to the horizontal, as you can see in the diagram. Okay, show that the normal component of the contact force acting on the ring has magnitude 3.05 Newton. Correct to three significant figures. Okay, so first thing first, we are going to mention all the forces which are acting on the ring. Okay, so first of all, we have the weight of the ring. Okay, since the mass is 0.8 kg, so weight is 0.8 g Newton, and in the opposite path upwards, we have the normal contact force, which is perpendicular with the rod. And since this force of magnitude 7 Newton is acting at an angle of 45 degree to the horizontal, so the horizontal component along the rod would be 7 cos 45, because this is adjacent with this angle 45, and the component which is perpendicular with the rod, it would be acting up. Okay, and since this is opposite to this angle 45 degrees, so this is 7 sine 45. All right, and since this 7 cos 45 would be trying to pull the ring towards the right, so the friction would be acting in the opposite path. So what's happening over here is that the ring is in equilibrium. Okay, so basically the forces are balanced. All right, so what we are going to do first, we are going to find the value of R. We need to show the value of R over here in part 1. Okay, so R plus 7 sine 45, they are acting in the same path, so they are added together, and we are going to subtract the weight. So we are going to subtract 0.8 g, and this whole thing is equal to 0. Okay, even if there was some acceleration, so even in that case, the sum of the forces which are acting perpendicular with the plane would be equal to 0. Okay, so R is equals to 0.8 into 10 minus 7 sine 45. So R is equals to 16 minus 7 root 2 divided by 2. Therefore, correct to three significant figures, we have shown the value of R as per the requirement of the question. Okay, this was worth 2 marks. Then in part 2, it says that the ring is in limiting equilibrium. Find the coefficient of friction between the ring and the rod. Okay, so now the friction is basically, it's having a maximum value. So we can say that, 7 cos 45 minus friction, and this friction would be at its maximum value. So mu r. In place of friction, I have just replaced this friction with mu r. Okay, because basically this is the maximum value of the friction over here. So 7 cos 45 minus mu r is equal to 0. So therefore 7 cos 45 is equals to mu times r, and in place of r I've mentioned the exact value, 16 minus 7 root 2 divided by 2, because I'm using the value of r in my further calculations. Okay, so it's better to use the exact value in your further calculation so that you get the coefficient of friction, uh, a very accurate value as per correct to three significant figures. Okay, so basically we are just going to solve this equation. Okay, we are going to find the value of the coefficient of friction. So first I have mentioned the value of this 7 cos 45, which is 7 root 2 divided by 2. This 2 is gone over here, all right, and divided by 16 minus 7 root 2. So therefore the coefficient of friction is 1.62, correct to three significant figures. As simple as that. So this was basically handout question number 8. All right. Now let's move on to the next question. Handout question number 9. This is October-November 2010, paper 42, question number 1. A block of mass 400 kg rests in limiting equilibrium on horizontal ground. A force of magnitude 2000 Newton acts on the block at an angle of 15 degree to the upwards vertical. Okay. Here 15 degree is not angle with the horizontal, it is with the vertical. So we need to find the coefficient of friction between the block and the ground, correct to two significant figures. Okay, so first I've made a sketch. We have a horizontal ground and the block is having a mass of 400 kg. So the weight is acting vertically downwards 400 g Newton. And in the opposite path, we have the normal contact force, okay, which is perpendicular with the plane. And you know, this plane is basically a horizontal ground. Okay, so basically R is acting perpendicular with the horizontal ground. And what we have is a force of magnitude 2000 Newton acts on the block at an angle of 15 degree to the vertical. Okay, so 2000 Newton is acting in this way that the angle with the vertical is 15 degree. So you can also say that, you know, angle with the horizontal is basically 75 degrees. As simple as that. Okay, so what I've done, I've used this 15 angle over here, angle 15 degrees over here. So since this component which is going upwards, this is adjacent with this angle, so this is 2000 cos 15. And this component which is, you know, opposite to this angle 15 degrees, this is 2000 sine 15. This 2000 sine 15 is opposite to the angle and 2000 cos 15 is adjacent to the angle. Okay. Alternatively, you could have, you know, marked the forces in this way that, you know, this force is 2000 cos 75. Okay. This is adjacent with the angle 75. And this force which is going upwards, this component which is going upwards, this is 2000 sine 75. Okay. This is basically an alternative way to do this because, you know, 2000 sine 15 will be exactly equivalent to 2000 cos 75 and 2000 cos 15 would be exactly equivalent to 2000 sine 75. As you are studying a basic trigonometric identity since P1, that sine theta is exactly the same thing as saying cos 90 minus theta. I mean, you are using this identity, this ratio since O level in IGCSE math even. Okay. And cos theta is exactly the same thing as saying sine 90 minus theta. All right. So you need to be familiar with all of these ratios and identities which you have studied in pure mathematics. Okay. So this is basically an alternative way to do this. All right. However, I've just used that angle to the vertical, angle with the vertical 15 degrees. Okay. So it's enough. So here we have found what? First, we are going to find the value of R. Okay, because R is acting upwards and 2000 cos 15 is also acting upwards. So 2000 cos 15 plus R minus 400 G will be equal to 0. So therefore R is equal to 400 G, meaning 400 into 10 minus 2000 cos 45. Okay, I found an expression for R. Okay, which is 4000 minus 2000 cos 15. Cos 15, एंगल इज 15. पता नहीं, मुझे लगा शायद मैंने 45 बोला. R is equals to 4000 minus 2000 cos 15. Okay. So therefore, uh, when we are dealing with the forces along this horizontal plane, so one horizontal force is 2000 sine 15 and the other one is, you know, the frictional force which would be at its maximum value. Okay. Because you know, the situation is like this, that this block is in limiting equilibrium. Okay, so this friction is basically F lim, or you can say F max, or you can just simply say mu r. Okay, so 2000 sine 15 minus mu r is equal to 0. So therefore 2000 sine 15 is equals to mu r. In place of r, I have mentioned this complete expression, 4000 minus 2000 cos 15. So mu is equals to 2000 sine 15 divided by 4000 minus 2000 cos 15. So mu is equals to 0.25, correct to two significant figures. Okay, so in this way we have attempted this question. Okay, so for the sake of this video, short video, brief video, I've discussed these two possible questions over here. So see you in my next video. Stay tuned to my channel. Thanks for watching. Assalamu alaikum.